Dear audience, Tuckey is here before you. Today I am going to teach you about analysis of variance and post hoc in SPSS. At first step, I will teach you what is analysis of variance. Dear audience, in our last lecture, I have told you that the unpaired t-test, the independent t-test can be applied if we want to make a comparison between two groups, between two populations on mean. But if we want to make a comparison between more than two groups, between more than two populations, then the independent t-test cannot be applied. We must go towards analysis of variance for this purpose. If we want to make a comparison between 5 fertilizers, let us suppose, then the analysis of variance will be used to compare 5 fertilizers on, for example, average yield. If we want to make a comparison between 5 groups of individuals on average height, then analysis of variance can also be used. So, go towards step 2. Here I will tell you what are the cases, what are the assumptions, what are the situations in which analysis of variance can be used, and if these assumptions are not fulfilled, what should be done as an alternative. These are the assumptions of analysis of variance. Dear audience, the first assumption is the observations that are being used in analysis of variance must be independent with one another. It means that the observations don't consist the autocorrelation. If the observations are autocorrelated, then you must not use the analysis of variance. The second assumption is the samples that are being used in analysis of variance must also be independent. And the third assumption is the data should be, the variables should be normally distributed. The data comes from the normal distribution. If the data does not come from the normal distribution, you must go towards the alternatives of analysis of variance. And fourth assumption is the populations that are being compared must have the equal variances, and this assumption is also called the homoscedasticity. If we want to test the independence assumption, means we are going to test whether our data consists the autocorrelation or not, then we have to use the Durbin-Watson test. If we want to check the normality assumption of the data, we can use Kolmogorov-Sammartino test, Anderson-Darling test, or chi-square test of goodness of fit. At the third stage, if we want to check the homogeneity of variances, that is the equal variances, then Spearman rank correlation test can be used. Dear audience, if the normality assumption has been violated, then what should we do in this case? Here is a diagram before you people. If the normality assumption has been fulfilled, then you can use analysis of variance, and if this assumption has not been fulfilled, then you have to go towards one of the two options. At the first option, you can apply any transformation to your data and make it normally distributed, then apply analysis of variance. As a second option, you can use the non-parametric tests as an alternative of the analysis of variance. The alternate test as the alternative of analysis of variance in non-parametric tests is the Kruskal-Wallis test or Friedman test. Now go towards step 3. How to apply the analysis of variance in SPSS. My dear audience, before applying analysis of variance in SPSS, you have to follow the following little procedure. First, you have to write the hypothesis. This hypothesis is very important in order to use the post hoc in order to use the multiple comparison tests. The null hypothesis of ANOVA is, let us suppose we are going to compare 5 groups, then we can write the 5 groups are same on mean, and the alternate hypothesis will be at least one group is different on mean. Dear audience, keep in mind, if we are going to compare 5 groups and only a single group is different from the others, H0 will not be accepted. We have to reject the H0. In this case, as a result, we have to make a pairwise comparison. For this purpose, we have to go towards the multiple comparison test or post hoc. Secondly, you have to go towards any software SPSS or MX Excel, etc., and apply the ANOVA and get p-value. On the basis of that p-value, you can make the decision as if the p-value is less than 0.05, then you should reject H0, otherwise accept H0. Dear audience, now I am giving a little description about p-value. This p-value is the probability in favor of H0. If this probability is very small, it means that H0 is being less favored, so it should be rejected. Here I have written a model. According to this model, we have to put the data in SPSS or Excel file and apply the analysis of variance. We know that if we write y is equal to x, it means that y is the dependent variable and x is the independent variable. In analysis of variance, we have to write like this. In one column, we have to write only the data that will be called the dependent variable, and the other column, in another column, we have to write the labels, the names of groups. If we want to make the two-way ANOVA, then we have to make 2 columns of labels, and for one-way ANOVA, we have to make only 1 column of labels. For example, our one column named as data, in which original data values will be written, and the second column is the fertilizer, in which the names of fertilizer, the labels of fertilizers will be written, and third column in case of two-way ANOVA will be written as concentration, in which the labels, the names for concentration will be written. In this way, we have to put the data in SPSS file or Excel file and then apply the analysis of variance. Here is an example that will be used in SPSS. Effect of fertilizers on plant. A farmer wants to know which fertilizer is best for his parsley plants, so he tries different fertilizers on plants and weighs these plants after 6 months. In this case, our null hypothesis will be all the fertilizers results in same mean height, and H1 will be at least one fertilizer has different effect on plant weight. Dear audience, now go towards the SPSS and apply the analysis of variance, but keep in mind these null and alternate hypotheses. In SPSS, first we have to import the data set. Click on open, then click on data. Here is our data of parsley plants. Open the data here. Now, these are 2 columns. In one column, only the labels are written. 1 is for the fertilizer 1, 2 is for fertilizer 2, and 3 is for fertilizer 3. And in the second column, only the data. So apply analysis of variance. Click on analyze, click on compare means, then on one-way ANOVA. Dear audience, we have 2 boxes before us. First is dependent list and the second is factor. In dependent list, we must put the column of data, and in the factor list we have to put the column of labels, the column of names. So weight in grams will be substituted in dependent list, and fertilizer, the names, the labels will be substituted in factor list. We are not going to apply the multiple comparison test because we are not sure whether our null hypothesis will be rejected or accepted. If the null hypothesis will be accepted, then there is no need to apply the post hoc, then there is no need to apply the multiple comparison tests. Multiple comparison test can only be applied, can only be meaningful to apply if the null hypothesis in analysis of variance has been rejected. So check the results, click on OK. Here is the result of an analysis of variance. This is the p-value. On the basis of this p-value, we can say that this p-value is very less than 0.05, so H0 has been rejected. Here is our H0, all the fertilizers results in same mean. This statement has been rejected, and the second statement in H1 has been accepted. Now here at least one fertilizer is there who is performing different, and if we want to check which of the fertilizers are different performing, we have to apply multiple comparison test. So go again towards spss and apply the multiple comparison tests. Click on analyze, compare means, one way ANOVA. Now I am going to click on post hoc. Here are many post hoc, many multiple comparison tests are given before you. You can use according to your desire, according to the study. Let us suppose I click on LSD, the least significant difference test, the tuckey test, scheffe test, Duncan multiple range test. Click on continue. Now click on OK. Here is the result of multiple comparisons test. Dear audience, for example, I am going to explain about the tuckey HSD test. The group in which none means control group. If this group is being compared with biological, then the p-value is 0.8486. According to this p-value, the both group none and biological are performing same, and if we compare none and chemical, then the p-value is 0.021. This is significant p-value, and we can say that the two groups none and chemical are performing different. This is the interpretation, this is the explanation of results for multiple comparison tests. These are some additional results. After this, you must have to write a comprehensive statistical report on the basis of result given in ANOVA and on the basis of results given in multiple comparison tests. You can also make graphs for multiple comparison tests. So click on analyze, compare means, ANOVA, then options. In options you can make the mean plot. Click on continue, click on OK. Now here is a mean plot before you for three groups. None is at the bottom, biological is in the middle, and chemical is at the top. You can easily copy or export this graph towards any file, LaTeX or MS Word. Dear audience, stay tuned, keep watching our videos for next topics and next statistical softwares. In our next sessions, I will teach you about all these statistical tools in R and R Studio. Thank you very much. Keep on watching my videos. Subscribe my channel.